Okay, combustion analysis is a type of empirical formula problem, very good for hydrocarbons. Those are compounds that contain only carbon and hydrogen, or compounds that contain carbon, hydrogen, and oxygen. If you have other elements, it gets a little bit more complicated than this. But you push through excess oxygen, you're going to burn the sample in the furnace. It's going to combust and form carbon dioxide and water. You're going to use a water absorber to collect the water and a CO2 absorber to collect the carbon dioxide. The difference in mass of these two modules will tell you how much carbon dioxide and water you formed. And that's what the steps down here below say. You're going to weigh the sample, so you need to know the mass of the sample and put it in the apparatus. You're going to burn it completely. That's why you have excess oxygen. And then you're going to burn that and form carbon dioxide and water. You're going to collect the carbon dioxide and water, and you're going to weigh the mass of those modules before and after to figure out the mass increase so you know how much of each is produced. If you assume all the carbon forms CO2 in bullet point 4, and all the hydrogen in bullet point 5 becomes trapped in water, then we can calculate the mass of each of those from the mass of the carbon dioxide and water. But you can't do that with oxygen because I'm inletting in XX oxygen, and I can't say all the oxygen in the compound is from the oxygen goes into the carbon dioxide and the water. So if it contains oxygen, then you're going to have to calculate its mass by subtraction after you get the mass of the carbon and the hydrogen. After we know the grams of each substance and consequently the moles of each substance, then we can determine the empirical formula in the normal way. So if we look at an example here, we got a sample of isopropyl alcohol, 0.255 grams, contains carbon, hydrogen, and oxygen. When we burn that, it produces 0.561 grams of carbon dioxide and 0.306 grams of water, and we want to know the empirical formula of the compound. So let's take a look at this particular problem. We want to know the empirical formula. We got a 0.255 gram sample, which is the carbon, the hydrogen, and the oxygen together. The carbon goes to form 0.561 grams of CO2, and the hydrogen's all going to form 0.306 grams of water. Now we want to calculate from both of those, so we're going to start with the 0.561 grams of CO2. Carbon dioxide, if you add up its molar mass, which we won't do explicitly for time's sake, is 44.01 grams of CO2 to 1 mole CO2. Then we know there's 1 mole of CO2 to 1 mole of carbon. Now, we're going to stop and calculate there 0.127 moles of carbon, because we need that for the empirical formula calculation. Then we're going to say 0.127 moles of carbon times 12.01 grams of carbon per 1 mole of carbon. That's going to cancel, and that's going to leave us with 0.153 grams of carbon. Now, I'm not going to need that to get my empirical formula, but I do need it to get the mass of the oxygen. Okay, so then next part, 0.306 grams of water. And so water, if you add it up, is 18.02 grams of water per 1 mole of water. Now here's the wrinkle that most people miss. 1 mole of water is 2 moles of hydrogen. A lot of people forget this factor, then it throws your moles off by a factor of 2, which ends up being a problem. Later on, 0.0340 moles of hydrogen. Again, I'm going to need that for my empirical formula, but I'm going to need the mass to get at the oxygen. So we're going to continue 0.0340 moles of hydrogen times 1 mole of hydrogen on the bottom, 1.01 grams of hydrogen on the top. And that's going to give us, if you run it through your calculator, 0.0343 grams of hydrogen. Now, I need to figure out my mass of oxygen in the sample. So my mass is going to be the original sample mass, 0.255 grams, which is from the original problem. And then we're going to subtract 0.153 grams of carbon minus 0.0343 grams of hydrogen, which will leave us with 0.068 grams of oxygen. So if we take that mass, 0.068 grams of oxygen, we're going to divide through by 16 grams of oxygen per 1 mole, which will give us 0.0042 moles of oxygen. Now I need that. So now I'm just going to take these amounts that we've already calculated, 0.127 moles of carbon, 0.0340 moles of hydrogen, and 0.0042 moles of oxygen. Now, once you see that, now it's just a matter of taking the ratios. Since the oxygen amount is the smallest of the numbers, 0.0042 moles of well, it's oxygen, but we're just going to divide moles by moles and cancel, and then 0.0042 moles for that. Again, moles are going to cancel, and 0.0042 moles there. Moles cancel. So that's going to be 1. What you're going to find is that when you do the division, that's going to be about 3, and that's going to be about 8. And so the empirical formula for isopropyl alcohol is C3H8O, and that would be your answer.